Good morning. My name is Jared Gabriela Torres, and I will present the work entitled Effect of the Hardness of Two-Step Treatment Carburizing Follow Overeating on Free Machining Steel, AISI 12L14. The co-authors, Alejandro Altamirano and David Uriel Ordaz, we are from Universidad Autónoma Metropolitana, Azcapotzalco in Mexico City. 12L14 is a standard resulfurized and phosphorus carbon steel. Lead is also added in order to increase machinability. However, this extra ductility do mean that it's slightly weaker than comparable carbon steels. This alloy is widely used in various industries, including oil, energy, automotive, and medical. The objective of this research is to increase its wear resistance by thermochemical treatments. The typical microstructure of these steels is predominantly of ferrite with minor amounts of perlites, an additive inclusion of leads, manganese sulfides, and carbon inclusions. Experimental project. First, the samples were cut a cubic bar and cleaned, and then the power pack of carburizing was carried out by embedding the samples in a closed container containing a cemented mixture with 80% of charcoal, 10% of potassium carbonate, and 15% of calcium carbonate. The container was placed in a conventional furnace for 6 hours and air cooling. The carburizing layers shows perlite, following by boriding process during 2, 4, and 6 hours with a boriding mixture with 85% of borax and 15% with silicon carbide and air cooling. The micrograph of a transversal section of 12L14 steels with boriding show a sound morphology of the boride layer. For the sample at 4 hours, the depth layer was of 40 microns and microhardness of 1,400 borocarburized. Finally, the quenching treatment was relied by 45 minutes and water cooling. In this case, the microstructure present martensite in the layer and a hardness of 700 borocarburized. The morphology of the layer was flat and depth decreased in a 40% approximately. Conclusions. Borocarburizing process with borax as a borinizing agent was successful and constitutes an alternative to the salts commonly used and that are more toxic, as 3-methylborate. The optimal condition of boriding process was 4 hours with a depth of layer of 40 microns and microhardness of 1,400 hardness beakers. A resident times of 6 hours present a flat layer and decrease the thickness. Meanwhile, the hardness was of 1,300 hardness beakers. With the second stage of treatment, it was achieved an increase in the hardness due to the martensite phases in the microstructure. Thank you for your attention.